In this video, we're going to take a look at exponential equations solved using quadratic equation techniques. So part E here, for example 1, we have 25 to the x power equals 5 to the x power, and then we have a plus 6 afterwards. So if it was just 25 to the x equals 5 to the x, then we could be okay. However, this plus 6 over here really kind of screws things up a little bit. Now, one technique would be to rewrite 6 as a power of 5, which can get pretty ugly and tricky looking. So what we're going to do instead is notice that 25 here as the base of this function is 5 to the second power. So we can rewrite 25 as 5 squared, and we have 5 squared being raised to the x on the left-hand side equals 5 to the x plus 6. Then using our power property for exponents, 5 squared to the x power is 5 to the 2x power equals 5 to the x plus 6. And 5 to the 2x power is 5 to the x power being squared. So it's kind of like we flip-flop these exponents here, where we went from 5 squared to the x, and now we have 5 to the x being squared. Notice also we have 5 to the x plus 6. So we have an expression being squared. We have that same expression equal to that same expression plus 6. So it actually is quadratic in nature. With quadratic expressions, we have typically we have a variable being squared and a variable to the first power and then a constant as well. So like x squared plus 3x minus 1, we have the x's being squared. We have the minus 3x has x to the first power, and then the 1 is the constant. So we can use substitution to help us along the way. We don't have to use substitution, but to just make it look a little bit more familiar, like equations solved in the past. So if we say u is equal to 5 to the x power, then using substitution, we'll get u to the second power equals u plus 6, which then we can subtract the u and subtract the 6, get it equal to 0, and solve it. We'll get u is negative 2, and we'll get u is positive 3. Now, it's important to note that these are the values for u. These are not the values for x. So when we use substitution, we now have to go back and plug in this negative 2 for u, and then plug in this 3 for u as well. So when we do that, we get 5 to the x power equals negative 2, when we plug the negative 2 in for u, and we also get 5 to the x power equals 3 when we plug this 3 in for u. So for this one, we get, using your power property here, we get x times log base 5 of 5 equals log base 5 of 2. And for this one, we get our power property x times log base 5 of 5 equals log base 5 of 3. So log base 5 of 5 is 1. So this one gives us x equals log base 5 of negative 2. This one will give us x equals log base 5 of 3. Now, if we try to evaluate log base 5 of negative 2 is outside the domain of the logarithmic function. We can only take logarithms of positive numbers. So this first one yields no solution. It's an extraneous solution for x. It's an imaginary answer. There's no power we can raise 5 to and have it come out to equal negative 2 as far as real numbers are concerned. However, over here, log base 5 of 3, we get about 0.6826. So our final answer for this equation is x is approximately 0.6826, or as an exact answer, log base 5 of 3. All right, part F, we have e to the x minus e to the negative x over 2 equals 5. If you study calculus and you learn about what are known as hyperbolic trig functions, you'll see this left-hand side again. So, but in any event, you don't have to worry about that for now. So multiplying both sides by 2 to eliminate our fraction, we have e to the x minus e to the negative x equals 10. And rewriting e to the negative x as 1 over e to the x, so our negative exponent property there, we have e to the x minus 1 over e to the x equals 10. And if we clear out that fraction by multiplying everything by e to the x times e to the x is e to the 2x minus, this will clear out the fraction of 1, equals 10 times e to the x is 10 e to the x. So getting everything equal to 0, we have e to the 2x minus 10 e to the x minus 1 equals 0. So once again, we have something, a term being squared minus 10 times that term uh, minus a constant. So it's quadratic in nature. So we can use substitution if we like and say u is equal to e to the x. So e to the 2x is u squared minus 10 times u minus 1 equals 0. And this one is not factorable. So we would have to use the quadratic formula on it. Negative b plus or minus. I always take the absolute value of b. So I don't want you to forget to put the negative 10 in parentheses. So just take its absolute value and for b squared and you'll be fine. Minus 4 times 1 times negative 1 all over 2. We get u equals 10 plus or minus the square root of 104 over 2. Or when we simplify the square root of 104, it's 2 times the square root of 26. And then 10, 2, and 2 can all be divided by 2. We get 5 plus or minus the square root of 26. So e to the x is going to equal 5 plus or minus the square root of 26. So we have e to the x equals 5 plus the square root of 26. And we have e to the x equals 5 minus the square root of 26. Taking the natural log of both sides, we have natural log of e to the x, which we know is x, equals the natural log of 5 plus the square root of 26. Over here, we have the natural log of e to the x, which is just going to equal x, equals natural log of 5 minus the square root of 26. So if you want to use your power rule, you can. And you'll get x is the natural log of 5 plus the square root of 26. X is the natural log of 5 minus the square root of 26. Now, 5 minus the square root of 26 is a negative result. So this is an extraneous solution to our problem. However, over here, natural log of 5 plus the square root of 26 is about 2.312. That is our answer for this problem. X is approximately 2.312, or the exact answer for x is the natural log of the expression 5 plus the square root of 26. So, all right, that about does it for this video. Thanks for watching. I'll see you next time.